An ellipse is a set of all points in a plane such that the sum, so if you add up the distances from point P to 2 points on here, these are called the foci, it's going to be constant. So what I try to think about is think of like a string, and I can also add a video to this too, demonstrating it. Think of having a string that these two are fixed points, and you take a pencil with the string and you slide around. You will create an ellipse. So an ellipse are found in planetary motion. The major axis is a segment that contains its foci and endpoints. So the major axis endpoints are called the vertices. So if it's stretched out side to side or stretched out up and down, these are called the vertices of the ellipse. And the foci are always in between the vertices. Foci are points, vertices are points. So you could have an ellipse that goes up and down. So in that case, the number on the bottom of x squared is greater or is less. Over here, the number in the bottom of x squared is greater. So whatever number is greater, either the denominator of x squared or y squared, tells you if the ellipse is stretched out farther left and right or up and down. So the major axis goes side to side if it's stretched out this way. The minor axis goes up and down. We call these 2 points the covertices. So over these 2 points are called the covertices. So number 1, write an equation of ellipse that has a vertex at 0, 4 and a covertex at -3, 0. So I'm going to draw a sketch of this. So the vertex is at 0, 4 and it's centered at the origin. So another vertex, if it's centered on the origins over here, and the covertex is on the x-axis. So this is stretched out up and down. So what I'm going to do is I'm going to use the formula 1 equals x squared over. Now to figure out what goes in the denominator of x squared, I'm going to take the distance between the center and the covertex, because this is going side to side, and square it. So it's going to be 3 squared, which is 9. Ellipses are always plus in between here. And then I'm going to figure out the number underneath y squared by checking out the distance from the center here. Or taking this distance, which is called the vertical axis, halving it, so that's going to give me 4, and then squaring it, so that's 16. Okay, number 2. Find the foci of the ellipse with the equation. So I'm going to write this equation first in standard form. So to do that, I want this value over here to be 1. So I'm going to divide everything through by 36. So I'm going to end up having x squared over 4 plus y squared over 36 equals 1. So if I just sketch a graph of this, look what's underneath x squared. It's 4. So if I take the square root of 4, my covertices are going to be at -2 and 2. If I take the square root of 36, my covertices are going to be at -6 and 6. So these would be my covertices because it's going side to side, and this is my vertices because it's stretched out up and down. So to find the foci, what I'm going to do is I'm going to use the formula. The formula generally associated with the focus of an ellipse is c squared equals a squared minus b squared. So I have my a squared right here. This is a squared. And I have my b squared. So c squared equals 36 minus 4. And you just don't want to ever get a negative number. So you're not going to do 4 minus 36. So 36 minus 4 is 32. And then I'm going to take the square root of this. So this is going to be 4 root 2. But I want to use this to write as an ordered pair. So I know my foci are somewhere on the vertical axis. So my foci are going to be at 0, 4 root 2, and 0, negative 4 root 2. So at the end, you just have to make sure that you're on the right axis. Write an equation of the ellipse with foci at 0, plus or minus 4. So I'm just going to draw a sketch of this. So if the foci are on the y-axis, that means that, I'll sketch the co-vertices here, that means it's going to be stretched out this way. So I need to figure out what my a is, or the number that's going to be underneath the y squared. I have the number that's underneath the x squared, which is going to be x squared over 2 squared, which is 4, plus y squared over something equals 1. So to get that, I'm going to do c squared, which is 16, minus a squared or b squared, which is 4, equals underneath the y squared, which is 12. So this is 12. You don't even need to go through the mess of taking the square root when you're just trying to find the squared value. Second, number 4, write an equation for an ellipse that has a vertex of 0, negative 6. So right here, and a co-vertex of 3. So underneath the x, the a is 3, so that's going to be 9, plus the denominator of y is going to be 6 squared, which is 36. I'm not so hung up on the a's and the b's. I just look at what's underneath the x is going side to side, what's underneath the y is going up and down. And number 5, find the equation for the ellipse. So what I need to do is I need to set it in standard form by dividing everything through by 16 because I want this to be a 1. So it's going to be x squared over 16 plus y squared over 1 equals 1. So this is going to be stretched out side to side because underneath the x squared's greater. So the vertices are going to be at negative 4, 0, because the square root of 16 is 4, and positive 4 is 0. And the co-vertices going up and down are going to be at the square root of 1 is 1, so 0, 1, and 0, negative 1. And the foci I'm going to find by doing c squared equals a squared minus b squared. So the greater number is 16, so it's going to be 16 minus 1. So c squared is equal to 15, so c equals the square root of 15. Now the foci are on the same level or same axes as the vertices. So the foci are on the x-axis, so that means that my foci are going to be at negative 15, 0, and positive 15, 0. And then number 6, write an equation of the ellipse with foci at square root of 16 and co-vertices at plus or minus 8. So I'm going to have x squared over plus y squared over equals 1. So the co-vertices are happening on the x-axis. So on the x-axis, I'm going to put 8 squared, which is 64. And now I need to figure out what's underneath the y. So to do that, I do c squared equals a squared minus b squared. So I have the square root of 17 squared, which is 17, equals, now the co-vertices are going to be less, a smaller amount, than underneath the vertices. So this y squared is going to be bigger, so I'm going to write a squared minus 64, because that's b squared right there. So if I add 64 to each side, I'm going to have a squared equals 81. So this is 81. And then down here, we want to figure out if a truck that is 8 feet wide carrying a load that reaches 6 feet high above can clear the semi-elliptical archway. So you have this 8-foot wide truck and it's 6 feet tall. So the highest point of this arch is 11. So will it, we know that in the middle of the truck it can fit underneath here, but we don't know about if it's going to hit a corner. So what I'm going to do is I'm going to write the equation for this ellipse right here if I were to make this ellipse. So I'm going to go ahead and do that. I'm going to pause and write the equation. So if I came up with my equation with the axes going across right here is 30, so that means this has to be 15. So I put 15 squared underneath here, and then this part is 11 squared. So what I'm going to do is I'm going to think about if this was the origin, it's 6 feet, it's 8 feet wide. So this would be, think of this ordered pair as 4, and this ordered pair is 4, 6. So if I plug in 4 for x and 6 for y, I want this to be less than 1. Because if I plug in 4 and 6 and I'm greater than 1, that means I'm going to hit the ellipse. If it's 1, I'm going to hit the ellipse because I'm going to be right on the border. So I want this to be less than 1. So I'm going to plug in 4 for x and 6 for y and see what this is in my calculator. So this is approximately 0.34. So I still have room. So the truck is going to be fine.